Hello, welcome. My name is Andrew Lamb. This is a presentation I gave at the Boston Apache DataFusion Meetup on November 12th, 2025. I believe this one wasn't recorded, and so I just wanted to record my slides again in front of the computer in my room all alone, mostly so that I could post it online in case anyone else wanted to see it. So my name is Andrew Lamb. I'm a staff engineer at Influx Data, and today I'm the Apache DataFusion PMC chair. I went to the DataFusion Meetup. Apache DataFusion is a top-level, of course, Apache Software Foundation project. As all such projects are, it's Apache 2 licensed. There's a website, you can go check it out. And so basically, in this meetup last week, I wanted to give the following thesis, which is that DataFusion is this rocket ship of a project, right, as an analogy. It's taken off, and it's basically reached escape velocity, which means, in my mind, you couldn't really stop it if you want. Comes from Julian Ledem of Parquet fame. He likes to refer to as Parquet at this point. Like even if he wanted to stop it, he couldn't. It's become so. It's basically picked up a mind of its own, and I think DataFusion's gotten there too. I'm going to try to convince you of that during the course of this talk. But that's my thesis. So I'm going to talk briefly about what DataFusion is. Then we'll talk about how we got to where we currently are, where we are now, and of course where we're going. So what is it? I have to start every DataFusion talk with these slides. I love this analogy. I know it doesn't work for everyone, but I think it makes a really important point. So there's a project called LLVM that underlies many of the modern programming languages you are used and that you're used to using. And what LLVM does is it gives basically access to high quality code generators and debuggers and LSP integration and all that sort of stuff that you need out of a programming language. And that's important because a lot of that stuff is basically the same across different languages, and instead of having to rebuild that from scratch each time, you can just share it. Now that way of describing it sounds sort of like, well, it just saves some work, but I think really what that saved work does is it's allowed the programming language innovation we've seen over the last 5 to 10 years. So the reason Rust exists, Julia exists, Swift, all these new languages, right, which are really pushing the boundaries of what you can do with computer programming languages, the reason they exist is because you didn't have to recreate them from the ground up. Instead, they could build on top of LLVM and then just focus their development efforts on the things that made those languages special and unique, rather than all like the massive amount of work, even though it's well understood work, massive amount of work to generate the ecosystem you need for a real language these days. So the analogy, of course, is that DataFusion does the same thing for query engines, specifically vectorized analytic query engines. These days people basically understand, because we've done it 3 or 4 times now, 3 or 4 successive generations of products, how to build these fast vectorized SQL engines and query engines. And instead of rebuilding like the same thing yet again, you can use DataFusion. And that lets you, as an innovator, focus on whatever makes your product or solution special. So maybe it's custom languages, or how you interface with remote catalogs or remote data sources, data flow analyses, whatever it is. Like you can basically not have to reinvent the query engine. And realistically, unless you have almost unlimited budget, you're not going to be able to reinvent the same level of technology that's in DataFusion without a massive investment. So yes, again, means like, yes, you don't have to do as much work to build your system, but I think that misses the broader picture. The real broader picture is the existence of DataFusion enables applications that wouldn't have been possible previously because they just would have been prohibitively expensive. So what is DataFusion? There's a whole bunch of talks that you can go read about this. I have to have at least one semi-technical slide in any of my talks. So here it is. DataFusion's a query engine. This is the canonical description of how a query engine works. You have some way to describe what tables exists, how to get the data, and sort of specialized readers for different file formats. DataFusion comes with a bunch built in, such as Parquet, CSV, JSON, Arrow, and several others. Then you have some way for people to issue queries. DataFusion comes with a SQL front end, like a full SQL parser. Sometimes people forget that it's both a parser and a planner, so you can give it SQL strings that will generate queries for you, query plans for you. It also comes with a data frame API. Both of those, like everything else in DataFusion, you can extend, so you can add your own data sources, you can add your own front ends, aka your own query languages, or whatever else might generate that. Then there's 2 levels of representation of these query plans, but they're called relational operator trees. Typically in the literature, they're basically described data flow graphs DataFusion has two of them, which is pretty typical in query engines. There's a logical plan, which is a high-level representation of the data flow, and then there's something called execution plan, which would be called physical plan in other potential systems. So that's a lower-level representation of the execution plan that has more details like algorithms and optimizations and sort orders and that sort of stuff. And again, you can extend both in both places. There's a bunch of transformations and optimizations that happen at both these stages, and DataFusion has the APIs that are explicitly designed for you to extend and add your own both plan nodes and rewrites. Right? It's not like you have to fork it and just modify the code. There's actually existing APIs where you should be able to do it without the forks. And then for each of these operators, there's actually quite a lot of effort's gone into implementing specialized implementations of them. So special optimized sorts, joins, filters, hashing, expression evaluation, all that sort of stuff. And especially this time after several years, as I'll talk about later, the amount of effort that's gone into these is actually pretty substantial, and they're pretty fast. So how did we get to where we are? And we'll again go back to where we are in a second. I want to start first with how the project was named. So I didn't create this project. It was actually originally created by a person called Andy Grove, who's great. And when he was asked by Weston Pace for one of these blog posts why he called the project DataFusion, he said he basically has this algorithm for creating project names. So he takes words that are somewhat related to what the project was, like data, for example, storm, fire, that sort of stuff. Data, for example, and then he picks other random words that he thinks sounds cool, like fire, storm, and fusion, and he just tries to pair them together and comes up with the one that he thinks sounds the best. So in this case, he came up with DataFusion, but he also admits at that time in his life he was driving a Ford Fusion car. I put up a picture of a 2019 Ford Fusion car, which is when DataFusion was originally created, and so this is what it looks like. Perhaps that was the inspiration for DataFusion. We'll never know. But anyway, that's where the name comes from. So over time, here's the high-level sort of schematic version of the project's history. Obviously, this is not quantitative. This is my qualitative assessment of it. I'll talk a little bit more about specific milestones in a second. But basically, sort of from the early years, 2017, 2018, 1920, it was early on. It was not exactly it's a toy. It's the shiny new thing. It wasn't really ready for production by anyone except bleeding-edge early adopters. This is about when I started with the project back here. I think in 2021, 2022, that was the early adoption phase where the people who really wanted to be on the cutting edge or willing to put up with the limitations of DataFusion at that time used it and built systems on top of it. And that's when InfluxDB built version 3, and a bunch of these other systems were built as well. I think 2024 was a major breakout year. That last year was pretty crazy. We had Sigmod paper. We became a top-level Apache Software Foundation project. We appeared in the famous CMU database seminar series. A lot of people have mentioned that is where they first found DataFusion, and a bunch of other stuff that was great happened in 2024. And then in 25, we continued the momentum, and we actually saw several of the startups that had been created. I'll talk about this more in a few minutes. Startups that had been based off products that were built on top of DataFusion are acquired by major companies. So I think we're basically in this acceleration curve here, where I expect to see many more users over the course of the next year or two. At a high level, I'm not going to read all this. You can go read these. These are largely the blog posts from either Arrow or DataFusion. So very early on, Andy Grove publishes How Query Engines Work. That's was originally written in Scala, I believe. And back then, also 2016 is when the Apache Software Foundation first announced Arrow as a project. So this will come back in a second. So Arrow and DataFusion were intimately related early on. 2018 was the first public posting from Andy Grove about DataFusion. Basically, he said, I built this cool thing called DataFusion on my way to building something called Ballista, which he talked about a couple months later. But early on, Andy donated to the Apache Software Foundation, which I'll talk about later. And then early on, it was sort of incubated as part of the Apache Arrow project. And then throughout the rest of 2019 and 2020, it started gathering steam. In particular, like my personal first DataFusion commit was better error messages in August 2020, and we then continued on through the later parts of the year. By the time 2021 rolled around, we had major features like a memory manager and decimal type support. There was a lot of effort put in from Yukon and some other folks at eBay for that. There was also, around this time, we moved DataFusion to its own repository. We also announced DataFusion Contrib in 2022. DataFusion Substrate. DataFusion Contrib, I think, was very important because it took the pressure off just continually jamming new features into the core crate. So now there were other places where people could contribute and build things on top of DataFusion that were valuable for many people, but they didn't have to be in the core crate or core repo. And then actually also interestingly in 2022 is when DataFusion Substrate was first created, which it actually also by Andy Grove, to give you some sense of how prolific he has been. Some interesting points along the way is this 2019 job posting from Andy about the Ballista project was also when the first DataFusion job posting arrived. That basically the job posting said that they were looking for people with DataFusion experience, which is kind of cool. It's subsequently no longer available, but the blog post refers to it. Then also in this 2020, I wanted to point out the 2.0 release of DataFusion. And the reason it was 2.0 is actually because it was part of the Arrow project at that time, and actually in the Arrow repository, and the Arrow big mono repo would basically do big releases regularly. And we just, at that time, just followed the release versioning of the Arrow project. So even though Arrow was several years more mature than DataFusion, we just started, and so that's why we ended up with version 2 out here. And so instead of like many Rust projects, which sort of perennially stay in the 0 point something release, DataFusion, got onto these major releases, and so that's why we're on DataFusion 50 or 51 now. It's because we started way back then with major releases, and you can't go back. So that's how we started there. You kind of see this is now like everyone's heads down, just cranking out lots of great features between 2022 and 2023. There's lots of work that goes into rewriting the aggregators, the data sources, object store, all that sort of stuff. I, of course, wanted to point out in 2022, my favorite analogy starts showing up for this LLVM. Right? So that's actually been around, that analogy's been around for a long time. And actually, I wanted to point out in 2024, this is the breakout year, right? We started cranking out lots of things. DataFusion Comet was announced, and we started having our first in-person meetups too, in addition to the papers and the top-level projects. So we had our first in-person meetup in Austin, Texas, USA, corresponding to another event. And we also had our first meetup a few months later in China as well. So that's been pretty cool. The rest of 2024, again, we kind of cranked out, especially this CMU database bullet block seminar series. That, as I mentioned, many people have told me that's how they heard about DataFusion for the first time. We also were briefly the fastest engine for per K files in ClickBench. I have a plan to get back on the top of the leaderboard, but we're not quite there yet. And 2025, we've just been cranking along as similar as always. I have some slides later on in this talk that describe what we've done. And then by the time we rolled around to November 2025, here we are in Boston. So where are we in Boston now? Obviously, we're physically in Boston, but I wanted to give some summary of how the project is currently going. I would be remiss if I spoke about this and spoke about the project with not talking about how important I thought the ASF being part of the Apache Software Foundation was. I quote myself here as it's been a key. I think as slow and plodding the ASF sometimes might seem, being part of it, right? There's certain procedures that seem kind of old-fashioned. I actually think it's a perfect set of guidelines, and it's really been important to make sure that everyone understands what the community is like. Everyone feels comfortable communicating and being part of it, and it gives just enough structure for us to keep going without having to either reinvent a lot of that with our own foundation, and nor is it overbearing. So I personally think being part of the ASF has been a huge part to DataFusion's success. Give you some specific numbers of how that might have been helpful, right? We actually currently have, as when I made the slides a couple weeks ago, there were 903 distinct contributors. And I put a star there because how the Git history worked, because it was pulled out of the Git the Arrow mono repo. There's several hundred, probably 100 or 200 people there that were only that are Arrow contributors, not Arrow DataFusion people. But anyway, it's many hundreds of people have contributed to DataFusion over the years, which has been great. There's currently 18 PMC members and 54 committers. So those PMC members are the people who are in charge of stewarding the project, mostly by inviting other PMC members or committers to join. And committers, of course, are people who have access to write things to the repository. Another thing I'm also particularly pleased with is the most recent version. We're in the final phases of voting right now. Version 51 had 128 distinct contributors. Right, just imagine that. It's 128 distinct people contributing code to help make the project better. It's sort of mind-boggling to think, and that's over the course of a month and a half. In 2025, we also participated for the first time in Google Summer of Code, and we had a couple of meetups. And I'm hoping in 2026 we'll have more meetups. Now, in terms of sort of industrial adoption, these are the people I know who are using it. There's probably many more on here that I don't know of or I forgot, so please let me know if I have, and I'll add you to the next version of the slide. So we have a whole crew of startups like Flareon, Wayfair, Lakesale, and Bucket that are basically relatively early in their life cycle or their product life cycle, and they've chosen to build on top of DataFusion. We run I/O. We also have a bunch of mature startups now at this point who made the same decision these new startups did a few years ago and have now actually built their product on top, including people like GrepTime, obviously Influx Data, Rand AI, Spice AI, Cube, OpenObserve, a whole bunch of them. And there's also a bunch of established companies who have been using DataFusion internally, typically for their internal systems and processes, so like Apple, eBay, Datadog, and Viva, all sort of big companies that have big internal data systems that are they're using DataFusion to optimize. And also, as I kind of hinted before, we have the first crop of acquired startups. So SDF was acquired by DBT Labs, and Arroyo was acquired by Cloudflare. Both those were early startups, part of the new startup category a few years ago prior to them being acquired. Something else I think that's been really cool to see in 2025 is we've seen quite a few product announcements from larger companies. You can read the links on these slides if you want, but basically we've seen DBT announced its Fusion engine, which is built on top of DataFusion. EDB, which is the enterprise database, right? That's the Postgres company. Their new distributed analytics engine is built on top of DataFusion. Cloudflare announced R2 SQL. If you remember Amazon's ill-fated S3 Select, right? R2 SQL is something somewhat similar, but it actually works. Amazon discontinued S3 Select, but R2 SQL is for real and is built on top of DataFusion. It's going forward. And, so it's kind of cool. You can run SQL queries against data that's stored in their distributed object store. And then recently we heard Palantir Foundry. I just saw this in the docs someday, right there. Something called Pipeline Builders built with DataFusion too. So lots of cool things to see products coming out of big companies that are built with DataFusion. We've also seen this year a bunch, in addition to our paper from 2024 that was in SIGMOD, we've actually started to see DataFusion used in a bunch of academic research. Now, realistically, DuckDB is probably still the system that has the biggest mind share in the academic world, but where DataFusion's starting to catch up. So we have a paper that's coming up in VLDB 2026 about liquid cache from Zheng Hao and the University of Wisconsin-Madison. There's some interesting papers about using DataFusion to build RDF and Sparkle engines. Those are particular data models. There's an interesting one of the VLDB 2025 Best Paper Award actually used DataFusion and the Rust implementation of Parquet to show how to use the framework for self-decoding data sets. It's actually basically encoding WASM encoders and decoders in columnar file formats. There's projects that use DataFusion to implement biological, like genomic reviews. That's what this polar bio thing is. And then we started seeing our first master's students generating master's thesis with interesting projects that were built with DataFusion too. So the technical highlights of the project, right? So that's sort of all the stuff that's happening in the community. Now the technical highlights of the project, I started making this list, and it's sometimes it's got kind of overwhelming. Sometimes during the day-to-day sort of churn of just cranking out the software, you lose sight of all the stuff that's coming out, right? It feels like it takes forever to get stuff done. So 2025 major highlights included getting a stable FFI interface, which makes interoperating with multiple DataFusion versions much easier. We added a dynamic filter framework. That's Adrian from and the Pydantic guys did a great job building the framework that we can add proper dynamic filter pushdown, including top Ks and hash filtering, hash join grouping, basically sideways information passing. We also wrote a bunch of stuff about user-defined parquet indexes, both embedded in files and externally, that people started using. This user-defined logical types became much of a thing. I think it's still not quite as easy to do those as we might like, but it's getting better. We also added crates of libraries with Spark-compatible functions. There's a DataFusion tracing library now that makes it easy to integrate DataFusion-backed applications with distributed telemetry. We added async user-defined functions. We also recently upgraded the Parquet reader and writer so that it has much faster metadata parsing, like 4 times, and it has 4 times faster in particular. And it also now has modular encryption support, which has been a long-standing feature request. Thank you very much to the Google research people who helped that. Adam Reeve and Corwin, among other, and Rock. We've also made it easier to upgrade with upgrade guides. We have truth file explains and many more. So like the features that actually we did in 2025 is pretty substantial. So where are we headed? Right, in 2025, the last month and a half, and then 2026. Of course, I would be remiss any of my presentations. You might imagine I have to convince you to actually help. So where is it going to go? Well, it's going to go wherever the community, help take us. And I say this partly tongue-in-cheek, but it's quite true in the sense that it's not like I have an army of people that are out there just doing stuff that I want to or that anyone else wants to for DataFusion. It's sort of everyone's kind of focusing and helping push the project forward along the dimensions they think are the most important. So we have these discussions. The most recent one is 18.494, but you can go find previous ones as well, where we kind of publicly try to describe and discuss what we're planning on doing. Not as often that works pretty well to get people, other people to know that what you're up to, but realistically, we'll see. Maybe someone will show up with some great stuff. So stuff I'm personally very hoping to see in 2026, right? This is not the project per se. I don't think there is really someone who could speak for the project as a whole, but I can certainly speak for what I personally am interested in. So I very much want to see variant integrated all up and down the stack. So that's basically semi-structured data support. So that's, you want to load something like JSON in instead of putting it in a string column or like a JSON B type column. It's properly integrated with shredding, which makes it much faster. I also really want to see performance become again top of the leaderboard, top of ClickBench. Some people argue that's just a vanity benchmark. Doesn't really matter. While that's possibly true, I think it's really been helpful to focus our efforts to make real performance improvements. So we keep working on that. I'd love to see more mature user-defined functions, the types specifically to make it easier to add things like geometry and variant. I would love to see a real join planner. I keep saying this, but it'd be great to see, of course, and then also you get to work with Yana, who filed a bunch of tickets on those, and she also helped organize the Boston DataFusion Meetup. And I'm also sort of predicting, maybe hoping to see, is at some point we'll say, this version of DataFusion is going to become our long-term supported one, where we'll backport features and improvements and whatnot, but keep the API stable. And I think if we adopted a slower breaking release cadence, that would actually help other projects downstream. We wouldn't have to spend quite as much time always chasing and keeping versions up to date. So with that being said, thank you very much for listening. You made it all the way through. As always, we'd love to have you come help us. There's lots of stuff going on, right? We can offer you, everyone's welcome. We're an open contribution project. That doesn't mean we have infinite review bandwidth, but we try really hard. And there's really not that many places I think you get to work on database internals, with people who are interested in having your contributions. As always, we're always looking for people to help. So please, come help, have fun, have a say in what's going on, and that's my thing. So thank you very much. I hope you enjoyed this. I enjoyed making this presentation. It's kind of wild to look back at all the stuff we've accomplished the last couple of years and contemplate where we're headed. And with that, I will say thank you very much, and thank you.